Hello, today we're going to prove Pythagoras' theorem. The theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The theorem's actually ancient. The formula has been known since at least 2000 years BC, and the proof has been known since at least 500 years BC. If we draw a right-angled triangle with hypotenuse length C and the other side lengths A and B, then what we're really claiming is that C squared is equal to A squared plus B squared. So how do we prove this result? Let's revisit the right-angled triangle with hypotenuse C and side lengths A and B. We know that one of the angles is 90 degrees. Let's label the others theta and alpha. Now we know that the sum of the angles in a triangle is 180 degrees. We're going to use this result for our proof. Because the angles sum to 180 degrees, it follows that theta plus alpha plus 90 equals 180. Making alpha the subject of this equation means that alpha is 90 minus theta. Now let's construct a new figure, a square with side lengths a plus b. We're going to divide each side of the square into lengths a and b, and then we're going to join up those points to make a four-sided figure inside our square. Now we know that the triangles are all similar, so we can mark on the A's and the B's, and also the hypotenuse length C. We can also mark on theta and alpha, which of course is 90 minus theta. Now the angles on a line sum to 180 degrees. So it follows that the angle of the internal four-sided figure must be 90 degrees. In order that theta plus 90 minus theta, which is 90, plus that other angle is 180. What we've really shown is that the internal four-sided figure is actually a square. Now we're going to think about the area of the large square. The area of the large square can be calculated in one go, knowing that the side length is a plus b. But actually it's also equal to 4 times the area of each triangle plus the area of the internal square. Now the area of the enclosing square is simply a plus b all squared. The area of a single triangle is just a half base times height, in other words a half AB, and therefore 4 times the area of the triangle is 4 times a half times a times b. And finally, the area of the smaller square inside is c squared. If we expand the brackets, we get a squared plus 2ab plus b squared equals 2ab plus c squared. The 2ab cancels from both sides, and what you're left with is a squared plus b squared equals c squared. So there we have it, a proof of Pythagoras' theorem, really resting on 2 assumptions. 1, that the angles in a triangle add up to 180 degrees, and 2, that the angles on a line add up to 180 degrees. Thank you.